Hi, and welcome to day 5 of rational expressions. Today we are adding and subtracting rational expressions. So let's get started. The one thing we know we need to have when we add and subtract fractions is a common denominator. So the first problem is to calculate the following sum, 3/10 to 6/10. Well, I already have a common denominator of 10, so I can go ahead and just write it as 3 plus 6 over 10, which is 9/10. That does not reduce, so I don't have to worry about it. I am done. Now, for all the rest of them, we're going to have to find a common denominator. So let's start by making a list of steps. The first thing we have to do is factor all denominators. And then 2, once we factor all denominators, we need to find our LCD. Number 3, we need to rename our fractions. And then 4, we need to add and subtract numerators only. And then 5, we need to factor again if possible. Most times it's not possible, but every once in a while it is. And then 6, we're going to reduce, which is just to cancel. Okay, so looking at number 2, the first thing I want to do is find my LCD. And my LCD between 20 and 15 is, oh, hang on. Sorry, is 60. Here we go. Now, I need to ask myself, what do I have to multiply 20 by to get 60? And that's 3. So I need to multiply the top and bottom by 3. And what do I need to multiply 15 by to get 60? And that's 4. So I need to multiply the top and bottom by 4. So what I have is 3 times 3, which is 9, minus 4 times 4, which is 16, over 60. So 9 minus 16 is negative 7 over 60. And that cannot be reduced, so I am done. For number 3, I have pi over 4 plus radical 2 over 5. I have to find my LCD. The LCD between 4 and 5 is 20. So I need to multiply the first fraction, top and bottom, by 5, and the second fraction, top and bottom, by 4. So I will have 5 pi plus 4 radical 2 all over 20. And again, I can't reduce that, so I am done. For number 4, now I'm not dealing with just numbers. I'm starting to throw some variables in. And I have m in my denominator, and I have 2m in my denominators. So my LCD is going to be 2 and then m. So this first fraction, I need to multiply top and bottom by 2. The middle one has everything, so I don't have to change it. And the last one needs to be multiplied by 2. So I have 2a plus b minus 2c all over 2m. And again, there's nothing in common, nothing I can combine, so that is my final answer. All right, for the next page, perform the indicated operations below and simplify. Well, the only thing that's really changed is our numerators at this point. Have changed just a little bit. Just like on the last page, when I have 4 and 5 as my denominator, my LCD is 20. This one is missing a 5, so I multiply top and bottom by 5. And this one's missing a 4, so I multiply top and bottom by 4. So what that really means is I'm going to have a 5 and then parentheses a plus b plus a 4 parentheses 2a minus b. I already know that my common denominator is 20, so I can just write it as one fraction. So the next thing I need to do is distribute. So I have 5a plus 5b plus 8a minus 4b all over 20. Now I see I have some like terms with the 5 and the 8. So that gives me 13a. And then for the b's, I have a 5 and a negative 4, so it is plus b all over 20. And again, that one cannot be reduced, so I keep going. I'm not done. Next problem. For b, in my denominators, I see a 3, an x, a 5, and an x squared. Well, the LCD between 3 and 5 is 15. So the LCD between the 3 and the 5 is 15. And the LCD between the x and the x squared is x squared, because remember, it's the smallest number of both numbers divided into evenly and the largest power that I see with the variable. So in my first fraction, I am missing a 5x, so I multiply the top and bottom by 5x. In my second fraction, I'm just missing a 3, so I multiply top and bottom by 3. So I will have 20x minus 9 over my LCD, which is 15x squared. And nothing factors, nothing cancels. I am done. Moving on. We finally get to a problem here where we actually have to factor our denominators. This is the first one we've come across, and that was the first step, I think I said. So this denominator here has a GCF of 2x, and I'm left with x plus 1. This denominator over here, my factors of 4 that subtract to give me 3 are 4 and 1, and it's going to be a minus 4 and a plus 1. So now, when I go to find my common denominator, I see a 2, I see an x plus 1, and I see an x minus 4. So it's 2x, x plus 1, times x minus 4. In the first fraction, what I'm missing is x plus 4. In the second fraction, what I'm missing is a 2x. So what I end up with is 3 times x plus 4 plus a 10x all over 2x, x plus 1, x minus 4. So if I distribute my 3, I'll have 3x plus 12 plus 10x all over 2x, x plus 1, x minus 4. See if I forgot to close parentheses up there. Now I'm going to combine like terms. I have the 3x and the 10x. So I have 13x plus 12 all over 2x, x plus 1, x minus 4. Now looking at that, 12 and 13 in the numerator have nothing in common, so I can't factor it. So I am done with that one. All right, here we go. Perform the indicator operations for each problem below. Well, just like we were doing, if the denominator is factorable, you must factor it. So this factors to 4 times x minus 2. So my LCD is going to be 4, and then x minus 2. And the first fraction, the only thing that I'm missing is the 4. So that means I will have 20 plus 3x over 4 times x minus 2. Can't factor anything in the numerator, so I can't cancel. I am done. For number 6, this looks strangely familiar, right? We have a m minus 3 and a 3 minus m. That's that -1 thing. So my denominator, common denominator, is going to be m minus 3. And to get that, I just need to multiply the second fraction by -1. So I will have 7m minus 5m all over m minus 3. So when I simplify, I have 2m over m minus 3. Can't factor, can't cancel. All done. Ooh, 7 looks like it's a lot of fun. So I need to factor that. The only way I can get b squared is with b and b. The only way I can get c squared is with c and c. My last sign's positive, so it means my signs are the same. They take the sign in the middle. So my LCD, when I'm looking at this fraction, I see a b minus c. And the assumption is you're done. But when you look in the first fraction, we have 1, 2 b minus c. Since we have 2 b minus c's, we have to have 2 b minus c's in our common denominator. So I have b minus c, b minus c. So that means nothing is missing in my first fraction. And in my second fraction, that's multiplied by b minus c. So that means I will have b squared, and this is a negative here, so that goes with the b. The negative b times b minus c all over b minus c times b minus c. So in my numerator, I need to distribute my negative b. So I have b squared minus b squared plus bc all over b minus c, b minus c. And if you notice, those two, when I add them, give me 0. So I'm left with bc over b minus c, b minus c. I can't factor that, so nothing cancels out. So I am done. The one thing you can do that I know some of you are going to ask me is, can't you write it like b minus c, the quantity squared? And the answer to that is yes, because there's nothing that can cancel out. All right, for number 8, we're getting there. I need to factor my denominators, difference of two perfect squares. X plus 1, x minus 1. My second one, it's x plus 2 and x minus 1. Okay, let's try this again here. My LCD, when I look at it, I see an x plus 1, x minus 1, x plus 2, and an x minus 1, which means I'm going to have an x plus 1, x minus 1, and an x plus 2. So in the first fraction, what I'm missing is x plus 2. I have to multiply by x plus 2. My second fraction, I'm missing an x plus 1. So I need to multiply by x plus 1. So I'm going to have x times x plus 2, and that's a minus 2x times x plus 1, all over x plus 1, x minus 1, x plus 2. So now I need to distribute here and then here, and I will get x squared plus 2x minus 2x squared minus 2x all over x plus 1, x minus 1, x plus 2. So when I combine like terms, my 2x and my negative 2x cancel each other out, and so x squared minus 2x squared is negative x squared all over this x plus 1, x minus 1, x plus 2. Now I know what some of you are thinking. Why do I have to keep writing that my denominator over and over and over again throughout the whole problem? I always have to have it there. Can I take a shortcut? Can I do something else? The answer to that is no. I apologize. It is not. You need to keep it there for proper notation throughout the entire problem. Okay? Last problem. Now, we've done complex fractions 2 different ways now, and I'm going to show you the third way because when I did this problem myself the first time, I tried it the second way we did fractions by multiplying by the LCD, the top and the bottom, the first top fraction and the bottom fraction, but it made it a very ugly and long problem. So I'm going to show you one more method for dealing with complex fractions. And since we were just adding and subtracting and finding a common denominator, that's exactly what we're going to do. So we're going to look at the numerator as an individual and the denominator as an individual, and then do a state change flip on it. So in the numerator, I have an LCD of 2b minus 1. And since I just have a 1 there, that's like saying 1 over 1, and I need to multiply it by 2b minus 1, top and bottom. So if I do that, I will get b squared plus b minus 1, and I have to distribute that negative, minus 2b plus 1 over 2b minus 1. That's just working with that numerator. And if I combine like terms, my 1's cancel, and I will have b squared and a positive b and a negative 2b, so minus b all over 2b minus 1. Now I have to go back and deal with the denominator and find a common denominator in the denominator. Well, that's a 4 over 1, and you can see in the denominator I only have b plus 1. So I must multiply top and bottom by b plus 1. So that will give me 4 b plus 1 minus 8 all over b plus 1. So this will give me a 4b plus 4 minus 8 all over b plus 1. Yep, nothing's going to change in my numerator quite yet. So b squared minus b over 2b minus 1 all over, I can combine like terms, I'll have 4b minus 4 over b plus 1. So this goes back to the very first day when I showed you a complex fraction where I have one single fraction over another single fraction. So now I can do a state change flip. Put my screen back up so I can see here. So I will have b squared minus b over 2b minus 1 times, and I'm going to flip b plus 1 over 4b minus 4. So now I need to factor before I can multiply. I will have b minus 1 over 2b minus 1 times b plus 1 over 4 times b minus 1. And in all that work, only the b minus 1 cancels out. So I'm left with b times b plus 1 all over 4 times 2b minus 1. That is all that can cancel. That is all that can factor. So that is the third method for dealing with complex fractions. I apologize, this was a little longer because we had a few more problems to get through.